Here we have some composite functions. We have inverse functions inside of trig functions. So let's look at the first one here. Remember that when we have an inverse trig function, it represents an angle. We could call that theta, and they're giving us the answer. We took the cosine of some angle and we got negative square root 2 over 2. But inverse cosine is restricted to be angles between 0 and pi. So we need to figure out what angle has a cosine value that's between 0 and pi of negative square root 2 over 2. So we know that's over here in quadrant 2, and that would be the angle 3 pi fourths. So now that we can replace what is inside the parentheses with 3 pi fourths, and we need the sine then of 3 pi fourths. So what is the sine over here at 3 pi fourths? And that's the y value, and that is square root 2 over 2. Now looking at this next composite function, we have an arcsine of negative 4/5, and that's inside of a cosine. So again, these inverse trig functions represent angles. Now negative 4/5 is not on my unit circle, so what I'm going to do instead is I'm going to draw a triangle. Now arcsine is restricted to the right half of the unit circle, and I've got a negative there, so I know I'm going to draw this triangle in quadrant 4. And my angle goes around here, but the reference angle is right here. And essentially I need to label the sides of the triangle so that the sine is negative 4/5. Well, sine is opposite over hypotenuse, so I label opposite and hypotenuse. And I recognize this. You could use Pythagorean theorem if you didn't, but this is a 3, 4, 5, so that is going to be 3. So now this triangle represents theta, and I need the cosine of theta. So cosine is adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5.